Well, hi there. This is Phil Simborg again, and I want to show you a bit of a lesson that I was giving the other day on end game cube action. And this is a famous classic position. It's called the four-roll position. It could be all 8 checkers on the 8 point, on the ace point, with 8 on the ace point, or this position. It's pretty much the same. And most of us know, just as a reference position, that this is a double and a take for money and for normal match scores. In this position, White has just under 25%, and the reason that he has a take is because there is a possibility that he could get in a recube, so his take point is really something a little less than 25%. He actually has about 24.7% here, and if Red were to roll a non-double, and White were to roll a double, and Red were to roll a non-double, White has an effective cube here. It's not the most efficient cube, but it's a big double and a pass. And because he can use the cube to win here in a situation where if he didn't use the cube, he could lose, that's why his take point goes down from the dead cube take point of 25%. It's just a good reference to know that four-roll is a double and a take. And, of course, three-roll is a double and a drop because White can never get an efficient recube, and his take point goes down to 25%, and he has less than 25%. In fact, he has a little less than 20% here in these positions. So I was giving this lesson to a student, and he said, well, I had some other positions that come up that were very, very similar to that, and I was telling him that you just interpolate from there and look at misses and possible recubes, and it becomes pretty easy. Well, he showed me a position, and it was actually, when I started to explain it, very complicated. And so what I did was, after I started explaining it and was starting to get tongue-tied myself on whether it was a take or a drop, actually the position, and we'll get to it in a minute, was this position. And I said, oh, well, this is fairly easy. Red's going to win if he rolls doubles and he misses with a 2, and then White's got a recube and and it got really complicated. So I said, wait a second. This really is a lot more complicated to explain and try and figure out whether it's a take or not, even for money, and then what happens when we get into match play. So what do I do when I get to these positions where I have trouble explaining them? I go to my go-to people. I have my partners at the Backgammon Learning Center, and my very best partner, and one of the best in the world, and who's also recognized as a giant when it comes to cube action and figuring out these positions, is John O'Hagan. So I've invited John today to take over and to be our guest lecturer to show us in a little bit more detail when these positions become a little bit different what to do. So, John, it's all yours. Take it away. I'm just your robot now.
All right, Phil, and greetings to everybody out there. And basically what I'd like to do is to start with a pretty simple late-game bear-off position. Phil, if you could put 2 checkers on the 2-point for each side, and the other 13 checkers born off, and now red on roll cube action.
Is it a recube or initial cube, John?
Well, recube in this case, yeah.
Okay.
So red owns a 2 cube. So when you're thinking about redoubling or not, the first question to ask yourself is the Woolsey rule, namely, are you sure the opponent has a take? Well, to answer that, you first want to look at how often does White win this game. Well, clearly, White will win if Red rolls a single ace, not double aces, and then White rolls a non-ace himself. So the chance of that happening is 10 over 36 times 26 over 36, which is 260 over 1296, which is a shade over 20%. So we all know that if you just take the cube and never redouble, you need 25% to win. So if White did not redouble after taking, and if Red then rolled a single ace and White just rolled the dice, you'd be making a big mistake. So the question is, how do you adjust for the fact that on those sequences where Red rolls a bad number, namely a single ace, and then White is going to redouble to 8. So we need to somehow adjust for that because in this position with White on roll now, a lot of his wins, all of his wins, will be worth 8 points. And, of course, all of his losses will too, but his wins will far outstrip his losses. So how do we adjust for that? Well, the concept was first explained by, as far as I know, by Danny Kleinman in one of his books. I don't remember which one. And the idea is he calls the concept doubling the difference from half. Now, let me explain what that means. Every roll, as we all know, you have 36 possibilities, and half of 36 is 18. So in White's position here, White's got 26 winners and 10 losers. Now, the difference from half, the difference between 26 and 18 is 8. So since White will be redoubling to 4, his true wins are...
He'd be redoubling to 8.
I'm sorry, he'd be redoubling to 8. His true wins, you double the difference from half. So the difference from half is 26 minus 18, which is 8. So you double that, you make it 16. And so it makes 18 plus 16. He actually wins 34 times. And so, therefore, his true winning chances are, go back to the original position, Phil, if you would. Red rolls a single ace, which is 10, and then White rolls any of his 34 winners, which is 340 altogether. 10 times 34 is 340, and that's a little over 25%, which gives him a take. Okay? So that's a good idea to keep in mind, doubling the difference from half. Okay?
So even though White has 20% and his dead cube take point is 25, because of the extra value that he gets when he wins so many by redoubling, it makes it a take.
Yeah, or if you just want to talk about it in general terms, a lot of White's, or actually all of White's wins will come with the cube at 8, and only a small number of his losses will occur with the cube on 8. Most of his losses will be with the cube on 4 because Red will bear both checkers off, right? So that's, so therefore, in terms of the true winning chance, when you take that doubling from difference from half concept into it, really, Red is about a 74-26 favorite in this position, not an 80-20, okay? Now, think about it in terms of wins or whether or not Red will gain or lose by redoubling here. If Red does redouble, when you take the 8 cube into account when he rolls a bad ace, he is a 74-26 favorite, right? And because of that, when you figure out his expected profit will be 4 times 74% minus 26% times minus 4. Or it'll just be 4 times the difference between 74 and 26. So that is 0.48, or 48% times 4. So in other words, his net profit will be 1.92 points per game if he does redouble. Okay? Now, ask yourself this. If he doesn't redouble and just keeps the cube on 2, how often does Red need to win in order to give him an expectation of this same 1.92 points per game? Okay. Well, it's actually, he's got to be an overwhelming favorite. He's got to be about a 98-2 favorite, because if he does win 98% of the time at 2 and loses 2% of the time with the cube on 2, his net wins are the same, 1.92 points per game. So the question is he a 98-2 favorite if he doesn't redouble and just rolls the dice? Well, obviously no, he's not, because the fact that the cube is basically, this is like the last roll of the game, and he's actually only an 80-20 favorite, as you can see here, if he keeps the cube. So that's the reason that redoubling is a huge mistake here, too. Now, also, I want to point out something here that's kind of interesting. The expectation, if you don't redouble here, you're an 80-20 favorite. If the cube's on 2, you'll win 1.2 points per game, right? Whereas if
where did you get that number?
You just subtract 80 minus 20 times 2.
Okay.
Yeah, so that's 1.2 points per game. And as we discovered earlier, if you redouble to 4, you win 1.92 points per game. So the error from failing to redouble is 0.72 points per game. Now notice that XG here, where it says no redouble, it shows the error being negative 0.352. And that is because the way it lists these error amounts is in something, is using a concept called equivalent to money games, and it's based on the cube at its current level. But the actual mistake is double what it shows there. It's not 0.352, it's actually 0.704. Okay, so it's important to understand that. Now I was using 0.72, that's just because of rounding errors, you know, where it actually comes to 0.704.
So why don't we ask Xavier to put the right number in there? Obviously, Extreme Gammon is as smart as John O'Hagan and could be able to figure that number out for us.
Yeah, you know, that's over my head. It's a good question, and I think some other people have looked into this, and it's still, for various technical, subtle reasons that I'm really not too well versed on, this apparently is still the best way to show the error amount. But
so I'll give Xavier a chance to answer that question himself, and we'll see what he says.
Absolutely.
Okay. I would like to know what the real error is when I'm making an error.
Yeah, and I mean, but the math is 100% clear. You know, if you redouble to 4 and you're a 74-26 favorite, on average, you're going to win 1.92 points per game. If you don't redouble to 4, you keep the cube on 2, you're going to win 1.2 points per game. So the real error.
If I had a pencil and paper and unlimited time, I would count the number of rolls that I win 4 points at, the number of rolls that I lose 8 points at, and so on, and come up with a total gain by giving the cube minus the gain by losing the cube. But what you've given me with Kleinman's formula is a shortcut that's going to make it faster and easier to come up with the number over the board. Is that what you're actually doing over the board when you see these positions?
Yes. That is correct, yes.
So that's one reason why adding a clock gives you such a big advantage over me, because you have all these shortcuts.
Well, that's partially true, I suppose, yeah.
Yeah, that's some of the importance of getting coming up with shortcuts, and that's one of the reasons I go to John on these. I have pages and pages of John from John on shortcuts, on how to quickly know what your take point is on an 8 cube and on a 4 cube, and he doesn't go through Neil's numbers and then risk over risk plus reward all the time on all these situations. He's got some shortcuts that gives him the numbers very quickly, and that's why he's going to be a huge advantage on Thursday when we play in the Giants events and we're playing speed gammon, because he can use the shortcuts. So that's what I've really been working on in my game. That's why this lesson is so incredibly helpful to me. My favorite saying, you don't know what you don't know. I didn't know Kleinman shortcuts. I probably haven't read I read Vision Loves Counting by Kleinman, but I probably didn't read the book that this was in.
Yeah, I don't remember which book it was in, but anyway. Okay, now let's look at your actual position there with 2 on the 3 and 2 on the ace for each side.
Let me tell you what happened. With my opponent, I was showing him, my student, I was showing him that, of course, when we get to a two-roll, it's going to be a huge drop. And he said, well, not too long ago, something very close to a two-roll came up. And he said, he says, I guess this is somewhere in between a two-roll and a three-roll. And since a three-roll is a drop, this has to be a huge drop. And I said, well, not necessarily. And I started to tell him how I would work this out over the board. And this is where I got tongue-tied and called you. So I'll let you take it from here.
Okay. All right. So here is Red on a roll, owns a 2 cube, and is thinking about redoubling. So the first question is, does White have a take? So let's think about that. If Red rolls double 3s or higher, Red will win. So White doesn't win any of those 4 games. How about if Red bears off 2 checkers and is gin to bear off his remaining 2 checkers on the next shake? How often does White win that?
By gin, what you're saying is, let's say that that red rolls 6-5, 6 with two high numbers, so that he's left with two checkers on the ace point. The other way that's not gin is if red rolls a 1, like a 6-1, then there is still some chance of losing here.
That is true, yeah. So now, just to keep things simple, I'm just going to ignore that little 2-1 vig on red's next shake, because the math gets too complicated to do in your head over the board. So it's such a small error that it's just not worth worrying about. But basically, there are 22 numbers where red will bear off two checkers and either leave the other two on his ace point or leave one on the 3 and one on the ace. And will almost certainly, or will certainly win next time if white does not bear off. So how often does that occur, and how often does white win? Well, there are 22 such numbers for red, and white wins 1/9 of those, because white will win 4 out of 36 if he rolls double threes or higher. So white wins 1/9 of 22, which is 2 4/9. Okay, almost 2.5 games there. Okay, and then
did you do that 2 4/9 in your head, John?
Yeah, I mean 22 divided by 9 is 2 4/9.
Okay.
Yeah.
Go ahead. I just wanted to point out that John, I'm going to be estimating these numbers in my head instead of doing exact calculations, and that's one of the reasons I'll be a little less accurate when I do these numbers.
Okay. So we've looked at, there are 3 main categories of rolls here for red. We looked at his joker 4 doubles that win right away. That's category 1. Category 2 is he's bears off 2 checkers and is either sure or close to sure to win next time if he gets to roll again. And the only remaining category is if red rolls a bad 2. So, Phil, if you could put one of red's checkers born off and the other one on his ace point, and then that checker on the ace, and now put white on roll, owning a 4 cube. And we want to know, should white redouble this? Okay. Now, how often does red win this game? Okay. First of all, if white redoubles to 8, if white rolls a single 2, red will redouble and white will have to drop, right? So that's 10 right there. And if white rolls any of his 4 winning doubles, he will win. And on the remaining 22 numbers, red will win 1/6 of those, right? Because I'm talking about sequences where white rolls like 6-5, 6-4, 6-3, something like that, and then white needs to roll any double to win, okay? So therefore, white is not that big of a favorite here. And in terms of cubeless winning chances, if white does not redouble, he does a little bit better in that sequence where he rolls a bad 2, because he will then, red will be on roll in a 2-roll position, and red will win about 86% of those. And the cube will not be, turned to 16, and white will have to drop. Instead, the cube will still be on 4, and white will win 14% of the time.
You know, John, this part of it was so simple for me. As soon as you said that every time that white rolls a 2, except for double 2, red redoubles and wins, and we know that's 10 rolls, immediately I know that's more than 25%, and I know he has a take because 9 out of 36 is 25%. So right. It's just a no-brainer that red has a take here.
I agree. I agree completely. And so the next question is, looking at it from white's point of view, given that we know that red has a huge take, should white redouble, or should he just roll the dice? Okay. So here again, we can use that doubling the difference idea to our advantage here. Let me make sure I don't get ahead of myself here. Okay, so basically, if white does redouble this position, he wins about, it turns out, about 62% of the time he will win, because he will lose right away on the 10 bad deuces, and he will lose 1/6 of the 22 numbers where he bears off 2 checkers and then white rolls a double. So therefore, white wins.
And what red rolls a double?
Yeah, red rolls a double. I'm sorry. So therefore, red wins 1/6 of 22, which is 3 2/3. Plus, he wins 10 when white rolls a bad 2. So that's 13 2/3, which comes to 38% for red, 62% for white. Okay. But the question is it still profitable for white to redouble this, or is it better for him to take a roll? And the answer is it's right to redouble. And the reason is that if he does redouble to 8, then he's a 62 to 38 favorite. And therefore, his profit is 24% times 8. 62 minus 38 is 24% times 8, which is 1.92 points per game. Okay. And
well, can't we make this a little easier? Isn't it right to double if it's a one-roll position if he's got 51%?
But this is not a one-roll position.
Ah.
Okay.
Well, if he doesn't, isn't it over if he doesn't take them off? If he doesn't take off 2 checkers, isn't the game over?
Yes.
Why isn't that a one-roll position?
Because it's over if red has the cube, but if
oh, I see.
Okay.
Oh, I see. Yeah.
So if white rolls a 6-2, then red will be on roll in a 2-roll position, and red will win that 86% of the time.
Ah, so if he doesn't cube, it isn't a one-roll position. He does gain something there by not giving the cube.
He does.
That's wonderful. Yeah.
Okay. So,
by the way, from a practical standpoint, if you're playing John O'Hagan or playing any really good open player, everything John is saying is true. If you're an intermediate player or in a chouette or something else, there's another reason why you must double here. You're going to get some drops. I know it's wrong to drop. John just proved that it's wrong to drop, and I understand that it's wrong to drop. But Woolsey's law, part of that tells you why you should give the cube even when it's close. But here you have a cube anyway, but you certainly will get some drops here from intermediate players.
Yes, that is correct. So, okay.
Now, this analysis you just gave us about white's recube, you were doing this as part of your analysis as to whether or not red should give the first cube, right?
Well, I was doing it to try to see if red could possibly gain enough by not redoubling to justify not redoubling.
Okay, so this analysis of white's recube was part of your initial analysis on whether red should give the cube in the first place.
Right, exactly.
So it is interesting to know what would happen afterwards, but it's also, I think one of the most important keys of this lesson is that before you give the cube, you must consider what happens when your opponent is holding the cube. Are you giving him cube vig or cube power, and how much power does he have as a result of getting the cube?
Right. Okay, so let's go back to the 2 on the 3, 2 on the 1 position again. Okay, so cubelessly, how often does white win this game? Okay.
Should I hit the button?
No. I'll run through it, and then you can hit it in a minute here. If red rolls one of the 22 numbers that bear off 2 checkers and leave them gin or very close to gin the next time, white wins 1/9 of those. Okay, so that's 2 4/9, and he wins 62% of the 10 out of 36 times that red rolls a bad 2. Okay, so in other words, cubelessly, white's winning chances are 2 4/9 plus 6.2, which is 8.65 over 36. Okay, so it's a shade under 9. So cubelessly, he's real close to 25% wins, but he's not quite there. Okay. Now, so the question is, if he does not have a redouble when red rolls a bad 2, then he should drop this. But if he has a redouble, that certainly will be enough to put him over the 25% threshold and make it a correct take.
And by the way, this is a major, major principle to keep in mind in these late game positions. If you're thinking about taking or dropping, one of the major reasons that you have to take is ask yourself, do I ever have a redouble, and how often will that happen? If you can't see many sequences where you have a redouble, that's a strong indication that you might have a drop.
Yes, exactly. Okay. Now, so if white, all right, so now let's go back to this position where red rolled a bad 2. So he rolled, take a checker off the 3-point, and then put the other one on the ace, and then put the cube on 4, and then have white on roll cube action. And so we've already determined that if white does redouble to 8 here, red will certainly take, and white will be a 62-38 favorite, which means he will win 1.92 points per game. Okay. So the question to ask yourself is, what kind of chances does white need if he keeps the cube on 4 to get to the same plus 1.92 points per game? And the answer is he needs to win it 74% of the time. He needs to be a 74-26 favorite with the cube at 4, because that'll give you 74 minus 26 is 48% times 4 is the same 1.92 points per game. Okay. So is there any way in the world that white can win this 74% of the time if he keeps the cube on 4 and just rolls the dice? And the answer is no. There's just no way. The reason is that if white roll, again, let's look at our 3 categories here. White rolls double 3s or higher. Well, the fact that the cube's on his side or on red's side makes no difference. So he doesn't gain anything there. How about when he rolls any of the 22 numbers that bear off 2 checkers and leave in gin to win next time? He basically gains almost nothing there, too. The only time he really gains anything is if he rolls an ace, like 6-1, 5-1, 4-1, or 3-1, and then white bears off 2 checkers, then he can cash the game because he'll be a 17-1 favorite. Well, that's not much of a gain. You know, rather than winning 34 out of 36, you win 36 out of 36. So it's hardly worth worrying about. You know, it's a tiny gain, but it's very small. Really about the only time that white really gains much at all is when he rolls a bad 2, because rather than being redoubled out of the game and losing 8 points, the cube's only on 4, and he still wins that 14% of the time. Okay. So
and the reason he wins it 14% of the time is when red doesn't roll doubles, and then white on his next roll rolls doubles.
Exactly. So therefore, the chances that white wins this game if he keeps the cube on 4, rather than being a 62-38 favorite, he's only increases that to about a 66-34 favorite. So he doesn't get anywhere near the required 74%. So therefore, if he does redouble now, he will win 1.75 points per game. Okay. If let's see, am I looking at the wrong ones here? This is the math on this is very confusing. Sorry about this. Let me double check this here.
No kidding. That's why I called you.
Let's see. Let me try to do this here. Okay, here it is. So therefore, if you are a 66-34 favorite with the cube on 4, you only win 1.28 points per game. Whereas if you're a 62-38 favorite, the cube's on 8, you win 1.92. So therefore, you win about 0.64 points per game extra. And I predict that XG's error for not redoubling, it'll show it to be about half that, about 0.32 or so. So let's see if I'm about right. .12. See, that's, again, based on a 2 cube, I think. Yeah, must be. So you have to ask Xavier about this because, you know, I'm sure these numbers are right.
60. Yeah, I'm gonna have Xavier look at this video, and again, since the beginning of XG, I've been a consultant to Xavier, and you can see I'm actually beta testing one of his new versions right now, and I'll make sure that we talk to him about this. A lot of the things you're seeing come from sessions just like this. A lot of things you see in Extreme Gammon are recommendations made by people like John that catch things that can improve it. And the nice thing about Xavier is he does listen.
Yeah. So basically, I come up with a difference of like 1.92 compared to 1.28, 0.64 points per game.
For those of you who haven't been lost, basically what John's saying is white is much better off and wins a lot more by recubing than cubing, because there is some advantage in not recubing, and that's when he rolls poorly, he might still win the game if he is still holding the cube, because he won't be doubled out. But when you compare what he gains by having the cube at 8 because he wins so much, it's clearly a plus for him to recube here. And what John is saying is he needed to understand and know that in the initial cube action to decide whether white should take or not.
Yeah. And that's all true. And so getting back to the initial position with 2 on the 3, 2 on the 1, and red owning a 2 cube, the main thing to notice is that anytime your cubeless winning chances are close to what the opponent needs for a marginal take pass, it's almost always correct to redouble, because of the fact that if you don't redouble, you need to win almost 100% of the time to get the same expected profit as if you redouble.
Okay, so over the board, you would not have actually done all of this math. You understand enough about positions like this to know pretty quickly that you would have a double and you would have a take here.
Yeah, I think basically, I would come up with, first try to figure out black's cubeless winning chances, and that's pretty easy to do, and that comes to just under 25%.
You mean white's
white. Yeah, I'm getting all mixed up here. White's cubeless winning chances are a shade under 25%. So you know that there's some cube big here when you roll a bad 2. So that makes it a take, but it's a close take. And the game's almost over, and you got a ton of market losers. That's something else we haven't really mentioned here. You know, if you roll any of the 4 high doubles, you win the game. If you roll any of the other 22 numbers and black fails to roll a good set,
white fails to, yeah.
Or white fails to, you've either won the game or you're a 17-1 favorite to do so. So you've got a ton of market losers. So there's
Okay, so I'm not going to go into other positions, but easily you could find yourself in positions that are different, that look like this, and positions that look like this, and you would have to use pretty much the same logic and reasoning almost no matter what these positions are, and then they can get also complicated by different scores, where it could be 3 away, 9 away, 4 away, 6 away, and now the take points and the recubes change tremendously. And the point is, with a clock, I don't think anybody has time to go through all the math.
Right.
So what's the point of going through all this math and learning all this? Because if you don't do that, and you don't understand the underpinning and the under logic as to why it was a double and why it's a take, and when you have recubes and when you don't have recubes, then you have no hope over the board of taking shortcuts and estimating, which you are probably going to have to do, of guessing and estimating a little bit to shorten the time frame. Even if you had all of John's math skills, and even if you had all his knowledge of all the shortcuts, most of us wouldn't be able to do it over the board without our clocks running out. And even without a clock, before our opponent spills a glass of water over our head, we wouldn't be able to get it done. So you have to learn why and how this works and what the math is involved in order to get there. So that when you get to a position like this or like this, you have a pretty quick idea of whether it's a double or whether it's a take, because you're not going to be so lucky to see this exact position again tomorrow or next week. Now, I know if I saw this position tomorrow, I would remember this, and I think I would remember this a year from now. But what happens when the position is this? It's slightly different. Then you get into all kinds of problems. You better know this kind of reasoning. Well, I proved today that I did the right thing calling John. I hope you all agree with me, and we also understand why he's one of the top-ranked players in the world and why he usually cashes in tournaments and why I'm afraid to play him and why he usually beats me when I do play him. But I hope we also learn that backgammon requires study, even in simple positions like this where you have 4 checkers versus 4 checkers. It's not so simple as it sounds. I hope you enjoyed this video. I hope you learned something. I want to thank John for his help. I'm going to do more of this. I'm going to invite John and other experts to help me with these videos for the USBGF, and I hope you all appreciate what the USBGF is doing by bringing in players like John and myself to give you these lessons as a benefit for joining the USBGF. Thanks a lot for your time, John. I'm going to replay this video a few times, and I'm going to find Kleinman's formula, because that's a great shortcut that's going to save me a lot of time in the future. And Danny's an old friend of mine. He used to live in Chicago. We used to play bridge together, and it's amazing some of the concepts that he's come up with that we all use today. He was just incredible. He and Walter Troyce in particular, and of course we owe a lot to Roberti and McGrill and many of the masters in the past that have helped us. But John is our new master. He's come up with a lot of shortcuts himself that are really helping us all. So thanks, John, and I will see you on Thursday at the Giants event in Chicago.
Sounds good.
All right, bye-bye.
Thank you.